it's a limit problem. They try to make you freak out because they make you find the limit of an integral. Don't, just follow the rules. So I remember the limit flashcard. X is not approaching infinity, skip that step. There's nothing to factor and divide, skip that step. Third option now, L'Hopital's rule. So I do the test. So for the test, I'm going to plug in x equal 1. Don't say it out loud, just raise your hand. If you're integrating from 1 to 1, raise your hand if you know what the result will always be. Just go with what feels right. You'll be right, I promise. If you integrate, if you start and stop the integral in the same place, what do you expect the value of the integral to be? Like, don't overthink it, just raise your hand. Just be brave, courage. Michaela. 0. It should feel like that's just the right answer, and it is. If you start and stop the integral in the same place, the result is 0. How many knew? 2 points, 3 for Michaela. So the first part of our L'Hopital test is successful. The top turned out to be 0. The bottom, plug in 1 squared minus 1. What is it? 0. So L'Hopital's rule works. So again, don't stress about it. Just use the rule. So now I'm going to take the derivative of the top. Okay, notice this is really important. So pausing so everyone sees. I've got to know whether to put dx or dt or whatever on the bottom here. With L'Hopital's rule, it's always the limiting variable. So we're doing everything in terms of x, so x. Tonight's homework looks weird when you look through the packet, but if you just follow the rules, you'll find out that it's really pretty quick. Just follow the rules. So I'm using the, oh, I messed up. This should be x, sorry. We're finding the derivative of an integral. So I look at my green sheet, and the derivative of an integral is, just take whatever's written here, whatever this is, write it down, but replace the input variable with the upper limit. So whenever I replace a variable, I always use parentheses, multiplied by d over dx of that upper limit. Minus. Anyone want me to talk through the rule on your green sheet again? Cool. Same thing with the lower limit, so that makes memorization easy. But d over dx of 1 is just going to be 0, so that's no big deal. Right here, dx over dx is 1, so the derivative of the numerator turned out to be really simple, just e to the x squared. Without saying anything out loud, please raise your hand if you know the derivative of the denominator. Raise your hand. Don't overthink, I just want you thinking, not just watching. Tori, what is it?
2x.
How many agreed? Point, 2 for Tori. So now you create a new limit problem. The limit, as x approaches 1, of e to the x squared divided by 2x. You create a new limit problem. And now you just go through the steps again. Well, it's not approaching infinity. Can't factor and divide. So it's either left-right limit or L'Hopital's rule. But here I can do the left-right limit, it works great. Because if x is close to 1, what's close to 1 squared? Close to 1. So the top's going to be close to e to the first, which is close to e. Just say it out loud, please. What's the bottom going to be close to? 2. We're done. We want to talk through that one some more. The rule. So if I were making a flashcard for L'Hopital's rule, trying to think of a way to make a card that's not too complicated, but will give me the key things I need, so memorization's easier. Test is first for sure.
0, 0, or
Or actually, maybe yeah, so for L'Hopital's rule, hold on. Test is to plug in limiting value. And you want to get 0 over 0 or infinity over infinity with who cares what the positive and negative is. So first thing, you don't ever use L'Hopital's rule unless you test first. And again, don't use L'Hopital's rule if the other items on the flashcard work. If the limit is x approaching infinity, compare terms that are adding first. If you can factor and divide first. Second item on L'Hopital's rule, you take the derivative of the numerator and you take the derivative of the denominator. And the third thing is you create a new limit problem. Of this derivative divided by this derivative. Question? So that's kind of how I talked you through it. Here's a more official, oh sorry, Sydney, please.
Wait, what's the, so it's the derivative of the numerator, what's the over the what is the h goes in?
What I was indicating is that in many limit problems, it won't always be this way, but in many limit problems, the limiting variable will be h.
Oh.
So you have to take the derivative in terms of that variable. But it could be x, it just depends. Here's a better way to write the rule, to be honest. This is kind of how we talked about it. Here's what you'll see in a textbook. It will say, as long as the test passes, the limit as h approaches any value, just call it a, of some function f divided by some function g. L'Hopital's rule says that limit is exactly the same as this limit. That's how you'll see it on, like if you Google L'Hopital's rule. They'll say as long as the test is successful, this is true. And that's what we're following. We're creating a new limit problem by finding the derivative of the top and bottom. Question? Take a second to write that down. Cool. Let's do another one.